again, this question is asking you to find non-permissible values, determine all the equations, determine the domain, and what we're going to do is we're going to graph, and by graphing we answer all of those questions. So first of all, to graph we need to factor completely. The top doesn't factor, the bottom is a difference of squares. So you get x plus 2x minus 2. Nothing goes away. We have our non-permissible values. That would be everything that makes us divide by 0. So x can't equal negative 2, and x can't equal positive 2. Because both of those would make us divide by 0. And then you have to decide, are your non-permissible values wholes or vertical asymptotes? And they'll only be a whole if it cancels out. Nothing cancels out here, so we know that we will have vertical asymptotes at x equals minus 2 and x equals positive 2. Next, horizontal asymptotes or oblique asymptotes. Look at the equation. This one has parabola on the bottom, line on the top. So we have a degree that's bigger in our denominator. Remember which type that was? Is that a horizontal or oblique? This is the easiest one. If it's bigger in the bottom, as x gets really, really big, the bottom will get bigger faster, and you'll always have a horizontal asymptote at y equals 0. Once you've got all your asymptotes, is the time where you can start drawing your graph. I'm going to draw my graph off to the side here. We already know we have vertical asymptotes. Oh man, I'm going to make made an asymptote. It's going to be very helpful. So now I can just click on that pen, draw a dotted line straight. Looks good. Oops, didn't work. So we label our asymptotes y equals 0, x equals negative 2, x equals 2. And now we get to the place where we do all of our nice points. So the easiest one to always find is your y-intercept, because you can plug in 0 for x. It usually makes sense to go to your original equation and plug in 0 for x. Do you see that you would get negative 4 over negative 4, which is positive 1. So we know on this graph, our y-intercept is 0, 1. X-intercepts. Find all of your x-intercepts. Again, you find an x-intercept by plugging in 0 for y. And in this case, by plugging 0 for y into the factored form, remember, the right-hand side is a fraction. And the only place a fraction is equal to 0 is if the numerator is equal to 0. So it's actually really easy to see that it has to be 4. The bottom doesn't matter. In fact, if you wanted to, you could multiply both sides by x plus 2, x minus 2. That would cancel out the bottom on the right, and the left-hand side is already 0, so when you multiply, you would still have 0. So to find your x-intercept for a fraction, you just need to find out where your numerator is equal to 0. So we have, and again, we saw this yesterday already, and it bothered us yesterday a little bit, that we have a point on our asymptote. But again, horizontal asymptotes are not non-permissible values. They just tell us what's happening when x gets very big, either very big positive numbers or very big negative numbers. Do we need other points? Yes. In fact, this time, again, other nice points. You need 1 point in each section at least. We have no points in this section. The vertical asymptotes separate our graph into 3 sections. So I'm going to need to plug in -3 to get a point in section 1. Okay? Again, I've got it here. Can you see that your numerator would be -7 when you plug in -3, and your denominator would be -1 times -5, positive 5. So we get -3, -7/5. We're going to estimate where that is. -3, -7/5. And once I have that point in that section, I will now know that it has to look like this going towards the asymptotes. Section 2, question.
This might be a little slow, but like, how do you know where -7 is?
I saw that it was 1 and 2/5.
It's like a mixed fraction.
It's like I changed it to a mixed fraction. I'm like, it's a little bit more than 1, but it's less than 2. So I estimated it in there between -1 and -2. That makes sense? Can you see that in the middle section we have a point already? And you have to decide, does it go up towards the asymptotes or down towards the asymptotes or a mix of both? Now, in this case, it has to go up towards the asymptotes because if it went down, we would have more x-intercepts. But we found all the x-intercepts already. That's why finding the x-intercepts is important for finding nice points, because you now know there are no more x-intercepts. 4 is the only x-intercept. So that tells us that section has to go up. And finally, we have a point in section 3, but it actually doesn't help us. Because I technically, from that point, could go up towards the asymptote or down towards the asymptote. So because you don't know, you use another point. So I would say plug in +3. If I plug in +3, my numerator would be -1. My denominator would be +5. And I would have 3, -1/5. That would tell me this part has to go down. I still also need some information about what's happening to the right of 4, 0. Is it going to go up a little bit more and then come back down to the asymptote? Is it going to bounce off and then go back up to the x-axis? Okay, so you want to find that out? Plug in another number. Plug in 5. If I plug in 5, that's another nice point. I'm going to get 1 on the top, and I'm going to get 7 times 3, 21. So it's going to go up for a bit. I don't know how high. Again, this unit will not tell us how high things go or how low things go, but I know that it's above, and over time it's going to come back down to the asymptote. So there's going to be a little bit of a bump here, that it goes up and comes back down. I don't know how high, but this will be the final graph. So this graph, we needed to find a bunch of additional points to be certain what it looked like. Part B. Again, step one, factor completely. The top is a difference of squares. The bottom is a difference of squares. Nothing cancels out. But -3 and 3 would make you divide by 0. Those non-permissible values will either turn into wholes or vertical asymptotes. Since they don't cancel out, they will both be vertical asymptotes. This is the one we have a parabola on the top and the parabola on the bottom. If the degree is the same on the top and the bottom, horizontal or oblique? Horizontal. We have oblique when it's bigger on the top than the bottom. But if it's either bigger on the bottom or the same, you have horizontal. And to find the horizontal one, it's going to be at y equals 1. You look at the x squared divided by x squared, the coefficients are 1 divided by 1, your horizontal asymptote is going to be at 1. So as a result, we can start our graph. Horizontal asymptote at 1, vertical asymptote at -3, and at 3. And we need some nice points. Again, the easiest one is your y-intercept. Plugging in 0 for x. I go back to the original equation. I get -4 over -9, which is just 4/9. Find that point. X-intercept. Plug in 0 for y. Again, look at the equation. In its factored form, it has to equal 0 in the numerator. The numerator is already factored. So what would it make the top equal to 0? -2 would work. And +2 would work. Our vertical asymptotes separated our graph into 3 sections. So if we're wondering, do we need any more nice points? Yes. We have no points in section 1. So we plug in a number into section 1. That would be -4. Can you see on the top? You would get -2 times -6, which would be +12. And in the bottom, you would get -1 times -7, which would be +7. So I go to my graph, I go to -4. 12 over 7 is just slightly bigger than 1, but less than 2. And once I have that point, I have enough in this section to draw it towards the asymptotes. The middle section. We already have points in the middle section. Do we know which way it has to go? Yes. And finally, we need a point in the third section. Okay? As a shortcut, if I look at the original equation, can you see that plugging in positive 4 does the same thing as plugging in negative 4? Because when you square it, it's going to be 16. So the fact that I already did negative 4 and got 12 over 7, I know that positive 4 will get 12 over 7 as well, as a shortcut. You could still plug it in and get 6 times 2 and get 12, and do 7 times 1 and get 7. It's not hard, but it's kind of neat to see that you get this same point over here. And there's our final graph. So we use these steps over and over and over again to draw graphs. Now, I'm going to give you a little bit of time to try graphing some of these. I know that I assigned questions 5, 6, and 7 yesterday. I'm going to add to that questions 9 and 10.